Very good morning to all of you. Very good morning to all of you. So we have to revamp the course one more time. So the course is Unix Programming, and Unix Programming already our course has been completed, but we would like to discuss the same one more time. For this particular time, we will discuss this particular course in slow manner. So daily, I'd like to consider only 30 minutes, not more than 30 minutes. Okay. So let us see what is this course and how this would be. The people who may not have this course in the previous time. So you please go ahead. This one here. So Unix programming or Linux programming. So Linux is a kind of operating system. Rather than operating system, we would like to consider as a kernel. Okay, as a kernel. There is a huge difference between Microsoft Windows and all other operating systems. If you consider Microsoft Windows does not have any kernel. The operating system routines will be directly communicate with the hardware. Whereas in other operating systems such as Unix, Linux, or Sun Solaris, or any other networking-based operating systems, operating system routines cannot directly communicate with the hardware. So, in between operating system and the hardware, there is one more component. That component is kernel. Okay, all system calls which are related to that particular operating system will be resided or will be executed at the kernel level. So that is the importance of the kernel here. We will go in detail about this kernel after 2 to 3 classes. And this kernel, in addition to this particular kernel, we also do have several number of compilers such as GCC, C compiler, Python interpreter, and Fortran compiler, and Pascal compiler. You do have many compilers and many interpreters. These compilers and interpreters are used to run some programming languages in our Unix operating system, and some editors are there, text editors, or what we consider word editors, or some other kind of editors are there. So VA editor, we have already gone through VA editor, Nano editor. These two are the text editors, and to have this word processing editors also be there with us. Open Office kind of editors also be there with Linux, not with Unix, Linux. And some number of command languages, SED, AWK, such kind of command languages also be available with us. And there is one utility is grep, is one familiar utility which is very much useful to us while you are doing some kind of operation with searching or doing some kind of regular expression parsing, something like that. We are supposed to use these utilities. And documentation, all these things will be considered as the Unix or Linux operating system. And basically, this Linux operating system is a time-sharing operating system. Time-sharing operating system in the sense, probably you people have gone through this CPU scheduling algorithms in our operating system course. In CPU scheduling algorithm, there is one certain kind of operating system. CPU scheduling algorithm that is round robin scheduling algorithm. So most probably this Unix or Linux operating system is being executed based on round robin CPU scheduling algorithm. Of course, nowadays it is not in round robin; it is in priority. As far as nowadays implementations of different flavors of implementations of Linux, it is under priority kind of operating system. But during the implementation of original Unix, so Ken Thompson has implemented using round robin time sharing kind of scheduling. So that is why it is time sharing operating system. And it was actually developed by, designed and developed by 4 people. Okay, so initially in 1969, Ken Thompson, he is Ken Thompson, and of course he is Dennis Ritchie. I'd like to say he is the father of modern computer science or modern computer languages, not computer science, computer languages, and Rod Kennedy and Doug McEvery. So these are the 4 people who invented, who written, designed and written this Unix operating system in assembly level programming, ASM, assembly level programming languages. Okay, and everything has been written by these people in 1969. But so understanding this ASM is not that much easy because 60% of ASM is in low-level language instructions, and 40% will be in what you call English kind of language, something like C, C++, or Python or COBOL, something like that. So it is somewhat difficult to understand. So that is why the revamp session has been taken by Dennis Ritchie and Ken Thompson after 1972. Because in 1972, Dennis Ritchie has designed and wrote the complete C compiler, After got this particular ANSI certification for this C compiler. So Dennis Ritchie and Ken Thompson has rewrote the same Unix operating system in C, Unix kernel into C here. It was happened in 1973. So after 1973, so C is a high-level language and it is user-friendly language, so that it could be understood by any user. Since C does not have any low-level kind of instructions with it, and it could be very easy to understand. So people are so able to write their own code in Linux, not actually in Unix. Unix is not open source. Linux is open source actually. So Linux also, 90% of Linux code also written in C programming language only. So that is why nowadays people are giving some suggestions and some utilities have been added daily to the Linux operating system. However, so in 1969, originally this Unix operating system's kernel was written by 4 people: Ken Thompson, Dennis Ritchie, Kennedy, and McCary. And this has been rewritten by Ken Thompson and Dennis Ritchie in 1973 after invention of this C programming language. Okay, and basically this C programming language, after writing of this particular Unix operating system, there are many changes in computer science world. So those changes will be like this. Is Richard Matthew Stallman. So nowadays people are getting some kind of software, some versions of software for free because of this particular person, Richard Matthew Stallman, and he was faced many problems in MIT while he is working with MIT. So for that, for those problems, he was come out from MIT and has introduced one particular project. That project name is GNU. So there is no full form of GNU here. GNU is one kind of animal in Australia and South America. So based on that is a peculiar kind of animal. So which is as like as since goat or sheep. So he has taken that particular name as his project name, and he was written some 12 postulates to write and share and distribute the software among many people. So that particular the kind of software is called as freeware or free software here. Okay, and In 1973, he was developed many number of rules and regulations, as such as so 12 rules have been written by Richard Stallman. So that is called as GPL, that is General Public License. General Public License. This license is free for everybody who are working with and who are using it. Working within the sense, the programmers or software developers will be work on that to implement some more extra features on so Unix or Linux operating system. Whereas using it in the sense, the people who are using that particular software, so it is for free. It was happened in 1983, sorry, 1983. Okay, and Linux was introduced in 1991. Actually, it is not introduced in 1991. So he is the Linus Torvalds. He is the person who is a computer science student at University of Helsinki. So University of Helsinki. So he is the computer science student, and he was taken up one particular project in his final year. So final year of BSc. So that project is later will be considered as Linux kernel, which is very very important nowadays, because people are not able to purchase the Unix operating system. So instead, so the Linux operating system is very much free and having many number of flavors also. And he was actually developed one particular software or one particular operating system in the name of Minix, MINIX. Okay, Minix. Why he has taken this particular Minix as his name in the sense, actually, so during the development of a Unix operating system, Ken Thompson has given one particular name to that environment. That environment name will be POSIX. POSIX. What does it mean? So portable operating system so extension. There is no there is no word for I here. There is no word for I. So portable operating system extension. So he has given one particular name as so POSIX. So from this particular thing, so he was inspired from this particular board and has taken this name as Minix here. Okay, and he was actually developed this particular Minix on 80386 processor, Intel 80386 processor, and of course it has been emerged with a very familiar operating system nowadays, and we do have approximately 16 to 20 different kinds of flavors are there. Flavor in the sense different kinds of companies have been developing this Linux operating system. So out of them, let me name them. Number one, Red Hat. Number two, Ubuntu. Number three, what is that? Uh, uh, one more operating system is Linux Lite. One more operating system. Likewise, 20 different kinds of 16 to 20 different kinds of companies are there. They have released their own Linux operating system. How it could be done here in the sense, because of Stallman's rules and regulations. Stallman has been written many number of postulates, as like as 12 postulates, which are so useful to share and distribute the computer software, whether it might be operating system or kernel or any kind of compiler or interpreter or utility, whatever it may be. Everything will be under shared mode only, distribute mode only. So that is why it was happened. So that is why 16 to 20 different kinds of companies have been providing their services on so Linux operating system. Originally, he is the person who introduced or who written this Linux operating system. Okay, and his Richard Stallman also so collected many number of compilers. They are called as GNU compiler collection. So that is why while writing any kind of a program in C under the Linux Unix environment, you may be execute the command which is used to execute will be GCC. So actually it is genuine, G in the sense genuine C compiler, genuine C compiler, which is under GNU C compiler collection, which is under GNU compiler collection only. So like this, it was introduced. Okay. and then followed by Unix or Linux operating system architecture. So there are several number of layers are there in Linux operating system. So very basic level will be, it is common for any kind of software, that is hardware. Hardware is common for any kind of software here. So in between the system call interface and operating system, we do have one particular thing, that is a kernel here. Okay, kernel will be always used to have its core of operating system. It's core of operating system, and whatever the internals of this particular operating system will be there with so system call interfaces. Then followed by GCC, let me say GNU compiler collection, that is GCC or what do you call Fortran or Pascal or Python or many number of compilers and assemblers will be there here. And followed by, you do have shells. Originally, user has been sit in this particular place, shell only. So we are supposed to use BASH. So this is the shell which was actually designed by Ken Thompson, and the CSH was designed by Dennis Ritchie. SH was designed by Brian Kenningham, and the KSH was designed by Kennedy. Okay, these are four different kinds of shells which are available, but nowadays people are evaluating, people are executing their commands with BASH only, not SH or KSH or CSH. So only using this one, so it has been taken into consideration. And followed by, after shells, we do have some number of application programs, such as different utilities are there. grep, many other commands, internal or external commands are available. So those will be after the layer of this particular shell. And then you do have the other applications, third-party applications, which are used to execute, or which are used to execute by this particular Linux or Unix operating system. X Windows is one kind of application program, and so video drivers, and then audio drivers, and then different kinds of other application software, which is activate different kinds of parts of your computer here. So this is what about the Unix or Linux architecture. You do have so this is first one, and second layer, third layer, fourth layer, fifth, 6 layers are compulsory. 7th layer will be based on your interest. If you are supposed to load, then that 7th layer could be gets existed. Otherwise, it shall not be. So up to 6 layers. So your Linux or Unix operating system must be there with you. Okay. So this is what about the architecture of your Linux operating system, and then followed by what is a kernel. Main components of Unix or Linux operating systems will be, number 1, the kernel, number 2, the shell, number 3, the file system, number 4, the developer environment. These are the 4 different types of components of the operating system, which is Linux or Unix. So developer environment will not be available for all. The person who is working with some components of the operating system, then they will come into the developer environment, and these 3 will be available for everybody. So number 1, kernel, number 2, shell, and number 3, file system. Everything will be available. So with this one here. So it is kernel is a specific program. Already probably you maybe studied something about semaphore or memory management schemes or CPU scheduling schemes. I believe that all these things have been completed in your operating system course. So thereby some controlling could be there. That controlling could be done by this particular kernel in any operating system. Okay, any a distributed kind of operating system here, and it could be it could be allocates some memory, and it could be give some permissions to execute some kind of some set of operating operations, so by this particular kernel only. And this kernel can be useful, or this kernel can be used to run their programs with that particular operating system and with that particular hardware also. So that could be done by the kernel only. And all peripheral devices are supposed to be activated and working properly with the help of this particular kernel only. So kernel can be control all peripheral devices, and it could be schedule all commands, and it could be execute all commands out there. So schedule in the sense, so if any program is being running, so if you require any memory, or if you require any kind of accessing of peripheral devices, probably you have completed one concept in our operating system, that is deadlocks. In deadlocks, normally what you are supposed to do, you have to allocate peripheral devices to the different kinds of processes. So-called peripheral device will be available, resources will be available properly, then your program or process will be gets completed in time. Otherwise, it must be wait for some time. Okay, wait for some time. So something like that. So all these operations will be there in operating system. So such kind of scheduling, such kind of allocation, such kind of execution, everything will be done by this particular kernel only. And then kernel could be manages file system and file structures. So what kind of file structure, how many kinds of files are there with you, all those files are supposed to be managed by kernel. And device management, so if any peripheral device will be there with you, that could be, so how that could be organized, how that could be allocated to one particular process for the completion of that particular process, and how these things will be. And if it is a disk, how the data will be transmitted or transferred from data disk to memory, main memory, or main memory to disk. All these kinds of scheduling can be done by kernel only. And process management, so daemon process in the sense the processes which are under sleeping mode continuously, they will be available, they could not be identified by your operating system, they are called as daemon processes. And such kind of process management will be done. And memory management will be done. In memory management, two different types of spaces will be very much required for Linux, especially, that is swap space and cache space. So these two are very much important for us for executing your operating system activity. And however, whatever the management schemes you have learned in our operating system, everything will be managed by, or activated by, or controlled by the kernel only. So these are different kinds of activities which could be done by the kernel. Okay. So we'll continue in the next hour regarding to remaining activities here. Okay. Probably still you people are some of you haven't put your numbers. So those who are not given your numbers, probably you could not get the attendance properly. So please remember. Please remember. Okay.